right? So there's and the whole intent of going back to development, deploy, and monitor is to move these ML models to production quickly. Now, there's also an ask across the organization and also across in the community is one second. Are you seeing this? Let me move this. Okay. Yeah. I think there's also a big ask on these platforms to go beyond machine learning. That's basically a holistic environment or a workspace where you can do your data analytics, engineering, and also data visualization. We see a lot of groups and a lot of interest in the business groups where they want to basically, we have the domain experts, but they don't necessarily have the data scientist or data science knowledge. And we want to give this capability in this environment where these domain experts could quickly go in, click on few things, do the data analysis, and maybe run there's a lot of market for these trained ML models as well to try this out. So the last point is really a big ask across the firm and across the AI community in general, because we want to scale and democratize AI as well, and not specifically limiting to the data scientists and the data science knowledge. That's a big ask there. So with this background, back at our firm, and also the main intent towards making these AI goals, one is to achieve speed, scale, and low cost while operating in an environment which is regulated environment. We're able to track and monitor what's happening in the environment. A training platform which can cater to data transformation, feature engineering, labeling, annotation, all in a workspace kind of environment where we can do everything together. So that's a big need of the hour across the community, AI community, and also at the bank as well. So moving on, looking at this, I've just highlighted few features which we think is essential for a platform, for a machine learning platform to have. One is the user-defined process. So as a data scientist, when you log in into the environment, you want to make sure that you're able to do things like data quality checks, cleaning, imputation, transformations. You want to do feature engineering, feature extraction, all that in one place. So you have you're able to pull in the right data sets from, it could be any host, would be the data. It could be your data lakes. It could be Amazon or on-prem environments, S3s. Third essential thing which we found was the lineage. Now, what I say lineage is you have picked up a data from a raw data set, you transform into a certain format, and it goes through multiple iteration and multiple transformation for various ML purpose. One should be able to, in this platform, look at the data lineage of this particular data, how it started, and where has it reached, and who all is, which all groups are using that particular one, and what all. And it's kind of leads to also an environment where you could collaborate this data set with multiple different groups as well. So that's something, a lineage is a very important aspect of your machine learning journey for any use case. So that's one thing we're looking for. And of course, the evaluation of these data sets. As you get refresh new data set all the time, you want to make sure that your evaluations are happening. It comes down to your model drift and things like that, which is you're able to do these as part of your monitoring as well. So key features includes the user-defined process. Then, as I said earlier, one of the big asks was no code or a low code kind of environment where you can do your data analysis or data visualization on a lot of these data sets with less knowledge of writing a code or scripting or running up instances. Another aspect we looked was the telemetry. I think I mentioned already the telemetry of the data, where you could see what all processes are running on your platform. You could audit log them, and you can see what processes are running. You can look at anomalies in these particular processes if there are any metrics associated with this. And then the metadata available on the platform for the user. So for example, you've created a new feature set. Now you want to know who the data owner was, what the kind of data it has. Let's say it's a house pricing index, what the source of the data was, and also what the volume of the data set does it has. So all that metadata information should be logged in the platform and available for people or the group at large to access. So these are the few key features which we highlighted. Now, what's the benefit of doing all this? Just want to give a few points there. So the benefit of this is, first thing, as we know, platform as a service. So at the bank and also at a lot of large organizations, we are running multiple experiments and curating multiple data sets. So we need one place or one-stop shop where you can look at these multiple data sets, and it could just exponentially help the other user base as well and the machine learning groups to use these featured data set and what it leads to the second point is not creating the copies of the data. You have a raw data set, you have the same, we came across a lot of groups using the same data set, that kind of creating the same features across different areas of their businesses. And that's where we want to reduce that effort as well. Enforce separation of data sets used for training and evaluation. So we make sure that your goal data set for training and goal data set for evaluations are strictly kept separated, and that helps for your evaluation and your training for the machine learning models as well. I mentioned earlier about the lineage. So automated lineage and built-in data quality checks for training data. So built-in data quality checks could be, as I'm mentioning here, missing data, the lack of labels. You want to look at the distributional anomalies, if there are any abnormal behaviors in the distribution of the data. So these issues should be automatically addressed by the platform. That's essential, so that it kind of gives you alert and tells you what's happening. Then first class integration of the visualization tools. So for the discovery, consumption, and reporting. So again, a lot of businesses have this question that whatever the ML groups are doing, or they're working with the particular ML groups, what kind of they want to look at these reports and charts and understand the data as well. And again, especially for the domain experts, we have, for example, a loan account where the mortgage loan officers want to look at the data and understand it. That's where I think it's really helpful for them to get the access to this platform and look at few anomalies in the data or things like that. And of course, as I said, monitoring, which is basically your seamless integration with ML ops and ML lifecycle management. So once you have trained the data, a data scientist has done through the experimentation stage, train the data, it should be seamless, be easily pushed this to production. And models are available for your online or offline, after the online offline training are available for serving as well. So that is something should be a capability we're looking for in the platform as well. Now, I just like to walk through that when we are envisioning this, how would it be for a flow of activity for a data scientist to get into a platform and see how does this particularly go, how does the activity of a data scientist goes on this platform. So let's say we have a data scientist, Anna. She she picks up few tables in the data lake, and she sees that, okay, this two tables are of real interest. What she should be able to do is just look at it, establish a connection to the particular data lake, assuming the data is in data lake, and just pick up, drag and drop these particular tables into her workspace. I'm assuming her workspace is the platform space, what they have. Now, let's say she picked up two tables, transactions and accounts. She's able to just get them copied in a workspace, as simple as that, with a just drag and drop. Now, let's say she wants to create a third data set by joining these two tables. She should be able to write an SQL query on this particular, once the data she's pulled in, she writes an SQL query. She calls this particular new table as T3. She has it available. Now in this, she doesn't want to include, let's say, credit card transaction. So she can do that as well. She can drop few columns, just pull only respective the required columns from the table, and she has a data set ready for her to do her ML on it. Now, for this example, let's take, she has a column called as zip code. Now, let's say she looks at the column zip code and she sees there are different type of zip codes. Some are 5 characters and 9 characters. She creates a rule there. Okay, identify the type of zip codes length I have. The other thing is she discovers that some of these zip codes are missing, and she looks at another city which has a zip code and she wants to copy the zip code from that. She makes another rule where she can copy this particular zip codes from this particular other cities to the missing values. Again, she creates 2 rules on this particular platform in her workspace, and the system automatically captures this as part of the lineage which I've been talking about, that you have already created 2 different patterns of different rules, and the rules are applied to this particular data set. Once that is done, now if you see, we have two different rules, and now she has multiple choices on this data set. Either she can fill the missing values with some hard-coded values, or she can exclude these records completely. You can just remove them. She can, or impute with the maximum value of the occurrences of zip code in a particular city. Now, there are 3 variations. As a data scientist, you want to try all the 3 of them. You don't want to just pick one at this point. You want to experiment. That's the experimentation stage. So now what she would do is she would create these data sets available. So now you have 3 data sets I'm calling them as T4, T41, T42, T43, available for experiments, 3 different data sets created. Further, when she jumps into feature engineering in this workspace, now let's say she creates feature like zip code. She has the option to use zip code as is, or she can do a one-hot encoding of the zip codes, or she can do a categorical variables, like assigning some variables to based on the zone or the city she is, the particular zip code is. Now, if you see this, 3 data sets got into, could explode to 45 different features. Now, 45 into 3, let's say 180 features of different data sets. The point I'm trying to make is it's going to get scaled out, it's going to get exploded, these particular data set. You need kind of a lineage recording, or a way to record this whole behavior across your platform to see, okay, from where the data set has started. If you see, you start with one column and we've gone up to making 180 features of the particular column of a zip code. So that's where it has to be tracked, very essential for your purpose. Now, on top of these 180 features, Anna tries multiple different models. We know one could try 8 to N and 8 to 10 different machine learning models. There could be deep learning models as well on top of it. When she tries all of it, for each of the feature model experiment combination, she can measure the metrics for each of these particular models on this particular platform, and then compare the model metrics as well. And again, as reiterating it, all of this is getting captured across the platform when you're doing it. So somebody can go in and look at what was changed. Followed by the lineage now. So let's say one particular model she identifies is the model they want to go with, and that's the baseline model. She can pick that model. Now, this whole process is a living document for her, and in generally for the team itself to look at it, that, okay, what all has been happening in this particular process. This could be used, the whole living document, I'm calling that as living document because it could be used for your quality checks, for cleaning the data again when the new data comes in, for the transformation, feature extraction, and experiments as well. And at this particular end state, when she's able to pick up this the final baseline model, for example, she should be able to push this to production when needed for authoritative training, for example, with the gold data set. Now, if another data scientist comes in, and, for example, they want to look at this particular data, the particular data scientist can look at the whole feature pipeline here, what has been done with this particular zip code. And they can pick up this at any point, the particular feature set, and then use it for their another machine learning model development as well. And that's the kind of collaboration we are looking at is happening across the bank, and I think definitely across your organizations as well. And we want to make sure that one thing is it is shareable, that what features we are making is shareable. There's a lot of knowledge around and information is shared to business as well on what changes has been done. And clearly this is expediting and accelerating your AI movement towards production. This is the kind of pictorial view of what we just went through in the flow of activities. So if you see from left to right, we took the raw data, we created some canonical data, did some quality checks, model training. And at the top, if you see, is you're pushing all this into a lineage database kind of environment where you have the lineage captured and available. And this process could be repeated again and again, depending on how your data is getting treated and how new data comes in. Few additional capabilities I want to highlight here, which has been also, when we looked around, was required. One thing is a data labeling tool, which I think is a lot of essential. It's good to have a data labeling tool. It could be used for augmented human labelers as much as possible. There's a big ask for that as well. And then the feature store. Now, once a feature is created, it could be stored in this feature store for offline reference, for ML training, and online for your model serving purpose. And feature store is again one of the things which has got pioneered a lot across multiple organizations, and should be an essential part of your platform as well if you're looking for a platform. As we went through this, few challenges which we have looked across. One of the biggest challenges is the complexity of the architecture. Now, as you want to scale this across the firm or across bigger organization, the architectures could really get complex and it could be difficult to maintain. And second thing is, when you're looking at a platform to select, you need to see if you have a lot of non-technical users, how easily can they learn this particular platform and use this as well. These are few of the parameters we are looking for in our platform to, when we're trying to work and select a platform. Again, if the platform is too complex, it'll take a lot of time to get it up and running and to make changes as well. And again, if you're doing anything at scale and across the firm, there would be a lot of custom requirement, custom demand. There are multiple data lakes, multiple different type of regulatory asks as well. So you would have to look at that as well to see how can you make sure that all these can be, it doesn't get too complex and you're able to do these as part of your platform. Third factor is the cost. I think everybody would have to look at the cost at the platforms, because again, when these platforms tend to scale and go high, the cost can really go up. And ML cost typically shoots up exponentially. There are a lot of numbers around there which could scale, which could add on to your machine learning platforms cost as well. These three are the few high level parameters we thought we could share that one should look out for in their ML platform. That's pretty much. Any questions, anything, or yeah, sure.
I was just wondering if there's any way for the customers to do different types of models and like pros and cons for their use cases.
Right.
Understand.
Yes, I think part of the platform, one of the points I mentioned was you could look at different model metrics as well, and also the metadata also, and what the models are. So once you log in the data lineage of the particular model, model, you would see all of it, how the particular data set was taken and what different ML models were applied to it. What are the metrics associated to that? That would be part of it. Was that the question around? Or?
Being able to explain why a particular model would be
all right, yeah. So I think so in terms of there are two parts of it, right? One thing is, why would one model be different? One thing is, of course, the metrics. You would have the metrics available. The second thing would be a bit you're getting into the model quality check and model drift as well. So that should be available as part of the platform too, where you're looking at if the model is behaving, why is it behaving in such a way, and why it's not behaving in a certain way. So of course, model drift is one aspect of it as well. Yes, we should be part of the platform. Yeah. Also, we looked a lot on the data quality as well. So abnormalities in the data, abnormalities in the missing data as well, corrupted data. Those things should be alerted by the system itself, rather than personal data and looking out for it. And yeah, go ahead.
This is probably a dumb question, but is the platform done, or is this proposal to create?
So I think we're still working on it. It's more of our findings and our understanding of how a platform should be. And I think we wanted to talk in that aspect, what we're looking for right now in a platform.
As I've heard from a lot of enterprise people also. One of the toughest things while doing ML modeling, etc., is we forget how much it takes us in compute costs.
Yeah.
And then we go off and we try to fight for compute resources.
Yes, yes.
So at the time of building these models, if the platform can sort of hey, this is going to be a cost estimate,
right,
etc., or historical cost estimate,
right,
other model,
right.
I think it's be super helpful.
Of course, yeah, I think that's true. And basically, when you spin up a instance to run your basic model, what kind of default configurations do you have? You get into detail of that. What kind of configurations you're looking for? So let's say if a use case comes in and they want to sign up for the particular platform, they should clearly define their compute requirement. Basically, there should be a discussion around that, and just not spin up things and things like that.
Because that helps from a budgeting perspective.
Exactly.
A lot of projects, we know immediately whether you can approve or disapprove, etc.
Yes, of course. Yeah. Sure.
Is there currently a product out there that sort of reflects or aligns as closely as possible with your vision or plans for your
Sure. I think there are a lot of things, a lot of people are products are trying to go to this space. H2O has some. There is Amazon Autopilot as well, SageMaker Autopilot as well. There's GCP's product as well. So I think there are a lot of players who are there in the market, getting to multiple aspects. What fits best for your organization, one would have to look at that. Yes, but there are products. Sure.
I'm curious, have you thought about data lineage across workspaces?
Yeah, I think good question. So data lineage across workspace, it's doable, but then again, it comes down to a lot of it comes down to your security aspect of it and the regulation of it. In our, for example, use case, we have the loan data. Do we want the loan data to be accessible to a credit card data customers and things like that? Just throwing out examples there. So it comes down to regulatory processes as well. Do you want to allow that to happen? Yeah, sure.
Curious, when you're determining what was the most important to build and what the platform had to have, what was the biggest pain that the teams that you kind of seen running the model, like, what were they not doing most likely? I mean, were they covering most of this and like it was a small increment to standardizing the process, or was there like certain areas that people just weren't doing?
Yeah, so so different stakeholders have different pain points. If you talk from the business pain point, there's some really talk about the cost and the amount of time to production. The time to production and the cost is the biggest pain point for them. How do we sort that out? There are multiple data sources available. How do you streamline them and able to connect to all of them with the regulatory and enforcements? From the machine learning and data scientists and machine learning engineers, one of the pain points I think is around one thing is the availability of the community sharing things. For example, the feature store kind of a thing, where we often find a lot of groups working on something like the same problem or from the same source of data set, and they somehow try to go to these forums or they try to connect and find a place. So feature store is one big thing which I think they're looking at a platform. And also a lot of tool support. So ML tool support is what they're looking for. Not all platforms providing all the tool support. If you want to scale your data set, let's say Spark, if you want to use Spark on your platform, is it available? What your computer is available to do Spark? That's, I think, two different things. I know it's all time, but I can take the question, please. Yeah, good.
I was just gonna ask, what's your complexity? How many teams, how many resources do you have working on this project? Do you have like one team and you've got the infra people and you've got the ML engineers,
Yeah.
data engineers, or is this like 100 engineers across multiple teams?
Yeah, I think I would say for us, we're looking at the organization level. So it's basically scaled out across the organization. So you can think of it definitely 100+ teams. But again, when I say ML platform, a very important thing, one size doesn't fits all. So it's going to be ML platform as much as possible, inclusive of various different components and to cater to multiple teams. It's a bigger scaled up environment you're looking at.
Do you mean you expect to have 100 different teams using the end product, or that there are 100 different teams right now involved in this planning and execution?
No, I think it would be the usability part, not the planning part.